This video lecture matches up with the course Chemistry in the Earth System, Unit 1.1. The topic is heat. The topic is heat. This lecture's essential question, which is number 1 out of 7 total, is what is heat? What is heat? Our first main idea for this lecture is heat itself. Heat. Heat is the transfer of thermal energy from a high temperature object to a low temperature object that are in thermal contact. Matter does not contain heat. Again, matter itself does not contain heat. Heat is energy in transit. Heat transfer will continue until the two objects are at the same temperature. When the objects reach the same temperature, they are said to be in thermal equilibrium. In spontaneous processes, thermal energy moves, in the form of heat, in only one direction, which is from the higher temperature areas to the lower temperature areas. Sometimes people speak of hot and cold, but in truth, these words are relative terms used to describe only the temperature of a substance, not the total amount of thermal energy in or of the substance. There is no physical process in which thermal energy is transferred from a lower temperature object to a higher temperature object, unless outside influences, such as work or force, will force it to do so. People sometimes express the movement of thermal energy by heat incorrectly. When they talk about cold weather, they may say that their house needs better insulation, quote, to keep the cold out, end quote. Now, what they mean is that they want to keep the thermal energy inside their house. Thermal energy always flows from regions of higher temperature to regions of lower temperature. If you hold a frozen snowball in your hand, heat flows from your hand to the snowball. The snowball melts because it's gaining thermal energy. Your hand, on the other hand, joke intended, gets cold because it is losing thermal energy. Our next main idea, heat and conversion of energy. Heat and conversion of energy. The law of conservation of energy applies to isolated systems. An isolated system is a distinct region that is closed off from its surroundings, from which no matter or energy can be added or removed. Objects within the system may gain or lose thermal energy, but the system's total energy is constant. Again, objects within the system may gain or lose thermal energy, but the system's total energy is constant. So any thermal energy lost by one object must be gained by another object. The total energy of an isolated system is conserved. One way to express this principle is to state that energy can neither be created nor destroyed, but it can be transferred to a different form of energy or transported somewhere else. During the manufacturing process, power plants and factories generate a lot of extra thermal energy. This, quote, waste heat can be recycled in one of two ways. It can be transferred to another type of useful energy, such as electrical energy. And a common method for converting thermal energy into electrical energy is to use that energy to make steam, the steam that drives a steam turbine. The steam turbine is a machine that generates electricity. Extra thermal energy can also be transported away from the factory or power plant and used somewhere else. The thermal energy is used to heat up water, and then that hot water can then be pumped into nearby buildings where it can be used as a source of heat. At this point, you should be able to generate an answer to today's essential question: what is heat? What is heat?